Today, we are diving into a pretty massive leap forward in artificial intelligence. It's a new model from Meta AI called DINOV3. And honestly, it's changing the game for how AI sees the world around us. It's teaching machines to see not just the big picture, but every single tiny detail inside of it.
So take a look at this. That glowing area? It's showing you every single part of the image that an AI thinks is similar to that one little point marked with the red cross. And what is just wild here is the precision. I mean, this isn't some vague blob, right? It's a detailed, almost high-definition understanding of the scene. And that new level of clarity? That is the breakthrough at the heart of DINOV3.
So why is this such a big deal? Well, it all starts with the big, ambitious promise of AI vision, which is the goal of creating one single, super powerful AI that can understand images for pretty much any task you throw at it.
And the bedrock of all modern AI is this idea of a foundation model. You can think of it like a master engine. You build it just once, you train it on a ridiculous amount of data, and then you can take that same powerful engine and just plug it into all sorts of different things, from analyzing medical scans to guiding a robot.
Okay, but how in the world do you train an engine that massive? Well, the key is something called self-supervised learning, or SSL. And this is a really brilliant idea where the AI basically teaches itself. It uses the trillions of raw, unlabeled images just floating around on the internet, and it makes up its own little puzzles, like, say, hiding a piece of an image and then trying to guess what it hid. And by solving these puzzles over and over and over, it starts to learn about the visual world.
And this matters so much because it unlocks a practically unlimited fountain of training data. It lets the AI build a truly general understanding of what things look like, not one that's just tied to a few specific labels. And this is a total game changer for really important fields like medical imaging or astronomy, where you might have tons of images, but almost none of them are labeled by an expert.
But as researchers started to scale these models up, making them bigger, training them for longer, they hit a really strange, counterintuitive wall, a paradox.
I mean, the logic seems totally obvious, right? Bigger models, more data, more training time, they should just keep getting smarter. And for a while, they did. But then something weird happened. Performance in certain really important areas started going backwards.
And here's the paradox right here. The model's global understanding, its ability to just look at a picture and say, yep, that's a dog, that kept getting better and better with more training. But its understanding of dense features, the ability to see the fine texture of the dog's fur or the exact outline of its ear, that actually got worse.
And this is what that looks like in the data. While the model got better at that high-level classification, its ability to do detailed stuff like segmentation just fell off a cliff. It's incredible, really. The longer they trained it, the worse it got at seeing the little things.
Let me put it another way. The AI was turning into a fantastic impressionist painter. It was amazing at capturing the overall feeling and the main subject of a scene, but it was completely losing the ability to draw sharp, precise lines. It was all vibe and zero precision.
So how do you fix a problem like that? How do you teach an impressionist to draw sharp lines again, but without making it forget how to paint these beautiful scenes? Well, the researchers at Meta AI came up with this incredibly clever solution, and they call it gram anchoring.
So if we stick with our artist analogy, the solution wasn't about forcing the model to go back and copy its old style. No, instead, they basically gave it a reference to its own early work, back when its understanding of detail was still super sharp, and told it, hey, just remember the relationships between the details you used to see so clearly. Okay, so here's how this actually works. First, they take a snapshot of the model from way early in its training. This becomes the reference teacher. Then, and this is the really clever part, they don't force the new, more advanced model's features to match the old ones exactly. Instead, they force the structure of similarities between features to stay the same. This whole thing acts like a gentle, corrective nudge, anchoring the model's sense of detail and stopping it from getting all washed out.
It's a really elegant fix. It basically repairs that noisy, blurry understanding of detail that was developing over time. But it does it without hurting all the powerful high-level knowledge the model had gained, so the AI could finally have the best of both worlds.
And the results of this fix, they're just stunning. This is where we get to see what DINO3 can really do. This is how it lives up to that promise of seeing the world in high definition.
Look at this, it just says it all. The feature map from the older DINOV2 model on the left, it's a noisy, chaotic mess. But DINOV3's view of that same dinosaur, it's perfectly crisp, clean, the shape is defined. The background noises, well, it's just gone. And you can see this high-def vision in action here. On an object discovery task, the older DINOV3 just struggles to separate the geese. The shapes are all muddled together. But DINOV3, it cleanly picks out each individual bird as its own distinct object. Easy.
With this incredible new level of detail, DINOV3 isn't just a small step forward. It's a whole new foundation for the future of computer vision.
And the numbers? Well, the numbers back it all up. On these really tough benchmarks, DINOV3 sets a new state-of-the-art. Just look at that first row, AGE 20K. That's a super difficult segmentation task that is all about understanding details. DINOV3 doesn't just squeak by the other models, it leaps way ahead. This is the hard data that proves they've finally solved that dense feature problem.
So this brings us to the really exciting question: what can we actually build with an AI that can see with this much detail? What new things are possible now?
Well, the list is long, and it's pretty exciting. We're talking about a new foundation for creating hyper-realistic 3D models from just a few photos, for robots that can interact with the world with way more precision, for tracking objects in a video with pinpoint accuracy. It even gets into crucial scientific work like estimating forest height from satellites to monitor climate change, or helping doctors spot tiny, subtle patterns on pathology slides. All of these things depend on seeing the details.
By solving this paradox of scale, DINOV3 has given AI a completely new, unprecedented level of visual sharpness. It is a foundational leap forward that leaves us with a really fascinating question to think about. Now that our machines can see the world in high definition, what previously unimaginable frontiers in science, robotics, and maybe even art will they help us explore next?